Well, my dear participants, I was talking about GOM call and GOM bar. Now, bar plots with two categorical variables. Let us begin with C. Bar plots with two categorical variables. Let us begin with a single ggplot. Data is equal to flights mapping AES, x is equal to character plus GOM bar. So, here we have taken only one character, only one categorical variable, and that is carrier, and this is the bar. Take two stack bar plot flights. See here x is equal to carrier and fill is equal to origin. So, we are taking into account two categorical variables, filling is by origin and x is equal to carrier, and GOM bar. So, this is the data, this is the output GOM bar. An alternate to stack bar plot or side by side bar plot, and that is position is equal to dodge. GOM bar position is equal to dodge. So, here it gives this position. See, say for example, origin EWR flights are very less, whereas John F. Kennedy flights are much more. Similarly, LaGuardia flights are less. So, these are two having lesser flights, whereas from John F. Kennedy there are more flights. But here you see the thickness of this. Here thickness varies. At some places they are more thicker, and at some places they are not thicker, they are smaller. So, how we could preserve this? For that, ggplot data is equal to flights, mapping is equal to AES, x is equal to carrier, fill is equal to origin, bar GOM bar position is equal to position dodge. But here we have to give the additional argument, preserve is equal to single. So, it will have the single length, single range here everywhere. It preserve is equal to single gives the same range. It is not somewhere thicker. When we give preserve is equal to single, it gives single range, single bin width. So, this is. Now, use facet wrap. See, ggplot data is equal to flights mapping AX is equal to carrier GOM bar plus facet wrap origin number of column is equal to 1, facet wrap origin. So, it will divide number of column is 1 and it is faceting as per the origin, like EWR's bar graphs, John F. Kennedy's bar graph, then LGA bar graphs, and number of column is n col is equal to 1. Now, we can have, say for example, number of columns dodged, number of columns C, and see what happens if we tell about n row. See what is the impact of this. See, this is the n row, number of row is equal to 1. So, it is EWR, John F. Kennedy and LaGuardia. So, number of rows is equal to 1, it has changed the scenario. So, this is the effect of faceting, number of rows and number of columns. N col, it gives this picture. Now, I shall talk about, so these were the graphics, we were talking about. Now, we can talk about tidy data, require modern type, require readr, and here we are defining an object daemon score which is read underscore CSV. This is the package developed by the Helly Wickham, and we can use this function read underscore CSV, any CSV file which is available on some website like moderntype.com. So, if we run this command, readr was built, yes. So, this is the data which has been read from moderntype.com data, then daemon score .csv. So, read underscore CSV has read this data from this website and it is reporting the results. In this daemon score data frame, the minimum value of -10 corresponds. So, these are the daemon scores, Say for example, daemon score of Albania, it is 999 up to 1982 and others also, whereas that of Argentina, it is minus and then plus. Then Australia's daemon score is very high, it is 10. Austria's daemon score is very high, whereas it ranges between -10 to +10. Belgium score, see, Belarus score is negative. So, it is very bad. After 82 it is still negative. Bhutan's, it is because it is not a democratic country. So, Bolivia, it has -4, -3. So, it is not democratic country. So, that is why these scores are negative. So, in this daemon score data frame, just I would like to go here. In this daemon score, this is a kind of table and it is country, and this is 1952, 1957, 1962, 1967, 1972, 77, 82, 87 and 92. So, these are the certain countries whose daemon score democracy. In this daemon score data frame, the minimum value of -10 corresponds to a highly autocratic nation like Bhutan. And note also that backticks surrounded the different variable names. Variables names in R by default are not allowed to start with the number nor include the spaces, but we can get around this fact by surrounding the column names with backticks. So, here we are having backtick also, Advantage of read underscore CSV. Note that read underscore CSV function included in the readr package is different than read.csv. It is in the base package function that comes installed with R, while the difference, it is a tidy words package rather, while the difference in, because it is available in readr and readr is a part of tidy words, and tidy word has been developed by Helly Wickham, and this read underscore CSV is also a function of readr. So, it has been developed by Helly Wickham, while the difference in the names might seem trivial, and instead of here we are using underscore instead of a dot. Here read dot CSV, here read underscore CSV. So, this is the difference. The read underscore CSV function is in our opinion easier to use, since it can more easily read data of the web and generally imports data at a much faster speed. Furthermore, read underscore CSV function included in readr saves data frame as triples by default, not as a data frame. So, these were the features of read.csv. read.csv. Now, we are going to talk about data visualization with ggplot2 and actually using R for data science. I have already talked about the two great books. One is Statistical Inference via Data Science by Ismay and Kim, and the other great book, that rather this is the greatest book, using R for data science, R for data science by Helly Wickham. Actually, R for data science by Helly Wickham 2023 is a great book. Actually, its first version came long back in 2014, but 2023 edition has a number of other features, like it discusses a lot about databases, etc. So, this is a great book on tidyverse. In this video, we are going to cover most of the material from that book of Helly Wickham et al. R for data science. We use the packages tidyverse for the analysis and graphics. So, we are using the package ggRepel library, Palmer penguins, and then library ggthemes, and then require or library, both are one and same, dplyr and glimpse. So, these are the packages which are needed. So, we require all these packages. Now, glimpse penguin. So, these are the glimpse. Glimpse is a function see here. We need to install for these packages, and then we can use library, then this, then library this. Here also we can use, instead of require, we can use library also, library. So, it is, and then glimpse penguins, it is Palmer penguin. So, glimpse is a function like this, glimpse, rows 344, column 8, and these are the species column, then eyes length, then bill length in millimeter, bill depth in millimeter, flipper length millimeter, and then body mass in gram, then sex, male and female, then year. So, these are the features of, actually glimpse can be used for other data frames also, like suppose data trees. So, these are the trees. So, if we use the function str, structure of the data, trees, it gives a short picture of the data frame, and here in R Studio it is glimpse. In R Studio, not R Studio, rather it is in dplyr, glimpse trees. Oh, could not find the function glimpse. Glimpse. Trees. So, here it is the glimpse. So, it gives the short summary and it is a better summary than the str, than the structure of data, because it shows the type of data also and number of rows and number of columns, and these information are also. So, glimpse is a better function than structure of the data frame. So, this is about the glimpse of the penguin. Now, see what the data penguin, because Sir Ronald Fisher says that you cannot escape from the responsibility of understanding a data which you are using or analyzing. So, first we have to understand the data, and that is why the exploratory data analysis and different tools are used to understand the data. The first thing is that just read the data. So, here we are using help to understand the data, help penguins. Help penguins. There is no need of keeping double quotes. You can also keep double quotes, but it is not required. So, help. See, penguins is a data object in the package Palmer penguins are documentation. Size measurements for adult foraging penguins near Palmer Station, Antarctica. And this is the description of the data. Includes measurement for penguins species, island in Palmer Archipelago, size, flipper length, body mass, bill dimensions and sex. This is a subset of this data. Usage, penguins, that you have to type penguins and you will get the data. Usage means penguins, you just type and you will get the data. This is the penguins. Then it is a form of a tibble, because here it shows the type. It is factor type. This is DBL. So, it is a tibble of 344 rows and 8 columns, species columns, and those 8 columns are species. A factor denoting penguin species, they are Adlai, Chinstrap and Gen 2. Then island, a function defining island in Palmer, they are Biscore, then Dream or Target. Then bill length in millimeter, a number denoting the bill length in millimeter, bill length. Bill depth, a number denoting bill length in millimeter, bill depth in millimeter. Flipper length in millimeter, an integer denoting flipper length in millimeter. Then body mass in gram, an integer denoting body mass in gram. Then sex, a vector denoting penguin sex, that is female, male. Then year, an integer denoting the study year, that is 2007, 2008 or 2009. Source, so these are the sources, from which this data frame has been created, data has been downloaded, and the data, this object, this package Palmer penguin has been created. So it might have been created by the ecologists. So this is all about data. Now graphics with ggplot2 using R for data science. So here R, we are writing a chunk R otherwise Python, gg2, this is the level of this chunk gg2, then message is equal to false. So if any message comes during the computation, that should not be printed. Warning should not be printed, because we want to generate the graphs. Document ggplot, data is equal to penguin, I have already talked about. Mapping AES, x is equal to flipper length in millimeter, y is equal to body mass. So we can run this. So this is the graph. Here we have set only the axis and not the GOM point. So that's why it is just setting the axis. And here we have added plus GOM point. So it will add the points also. See, flipper length, and it is adding the points also. So it is adding the points also, GOM point. Now adding aesthetic and layers, or layers, warning is equal to false, message is equal to false, ggplot, data is equal to penguin, and C, mapping AX is equal to flipper, Y is equal to this thing, color is equal to species. So now it will add colors also, and it will be decided on the basis of species color and then GOM point, because there are 3 species. So when we run, it shows the color of species like Adelaide, red or Adelaide, and then chin strap, they are the chin strap. See, Adelaide and chin strap, they are having lesser flipper length and body mass is also less, because they are in this part only. Whereas Gen 2, they are having flipper length more, and that is why it is in this part, higher part, and body mass is also more. So it is this kind of discrimination you can have by using the color. Color is equal to species. Then here we are having color is equal to species and GOM point, then GOM smooth. So here GOM smooth method is equal to, by default it fits non-parametric method lowest. So it fits for each species, it will fit a line. For each species it will fit a line, and line will be simple linear regression line, because it talks about response body mass in gram and flipper length is the variable. So it is y versus x. So for each species it will fill a line, because color shows that it should be distinguished by color also. So when we run this, see here it shows Adelaide So, this is the this line, fitted line, then chin strap, this is the fitted line, whereas Gen 2 is fitted somewhere here. So, these are the three lines in which slope of these two, Adelaide and chin strap, they are almost same. So, they are parallel lines. They are parallel lines. What it shows, as flipper length increases, body mass also increases with the same speed in both Adelaide and chin strap. Whereas, here the slope is higher than these, it is sharper, it is more sharper. So, that means in the case of Gen 2, it is also fitting this line and the slope of this one is more than the slope of this, and they are not, it is not parallel to these two lines. So, here growth is more as compared to these two. So, this is what, since we want points to be colored based on the species, but did not want the lines to be separated out from them, we should specify color is equal to species GM point only. So, now I shall continue after interpreting this graph. I shall continue in my tomorrow's talk on the same graphics. So, that is all for 2 days.